Okay, ladies and gentlemen, welcome back. Now, going on, vertical circular motion. Now, this one is very confusing if you don't pay attention. Now, if we're looking at stuff going in a circle, like I said, for example, a carbon nanotube, one of these new super materials, it takes 62,000 newtons of force to break it, which means you can hang, if you do the math, you can hang a 6,000-pound weight off of it. If this is a radius of 1.5 meters, and you've got a 10-kilogram weight hanging at the end of it, how fast can you spin it? Now, what am I asking you to do? Take a 10-kilogram weight and swing it in a horizontal circle. Now, is that a really good idea to do in this classroom? Yes. So let's just pretend I'm swinging it in a horizontal circle. The velocity and the direction is that way. The force centripetal and the acceleration are directed inwards. Now, I asked, how fast can you spin it without it breaking, before it breaks? So what's its velocity or velocity maximum? Now, what formula have we talked about with velocity and radius and mass and force in there? Well, what formulas have we talked about? Velocity 2 pi r over t, but that doesn't have force and mass in it. Hey, 4 pi squared r over t squared, isn't it? The other way to write it? Okay. And then we got force centripetal Can we use one of these formulas? Force, radius, mass, and ask for velocity. Force, radius, mass, and velocity right there. Now rewriting that, so swinging that weight, just pretend I'm swinging it in a big circle. Come on, you've all watched Game of Thrones. There's got to be one guy swinging a weight there. Now, and that's why I'm not swinging it. So, can we put the numbers in here and solve for velocity? And nobody's going to say anything. Can we?
Yes.
Yes. Can we? Now, I would rather rearrange the formula first, just because I want to get velocity out by itself. So how do I get V out by itself?
Divided by r.
Well, it's divided by r. So how do I get rid of divide? Times r. It's multiplied by mass. So how do I get rid of times mass? Divide by mass. So V squared equals r force centripetal over mass. And this is, frankly, one of the two hard parts of this entire unit. You've got to be able to rearrange equations. You could, if you really wanted to, make a list of all the variations, because you can rearrange these equations, solve this one for t or r or v or m. It's just too much. You have to be able to do it rather than try to memorize them. Now, excuse me. Thank you. Rf sub c. The radius is 1.5 meters, force centripetal 62,000 newtons, 10 kilograms. So velocity squared. Once you get to that point, Maybe. The velocity squared is not a problem. Somebody grab a calculator and tell me what the number is. Thank you, Ryan. Yes? Sorry? 96 is v squared or v? V. Thank you. I was asking for v squared. But, yes. I got about 93,000. No, sorry, 9,300. So, you can swing the heck out of that. 96 meters a second, that's what? 300 and something kilometers an hour? That's strong. Yes?
How fast does the propeller swing on the big?
I don't know, but we will be doing that as a calculation later. All right. Now, this, yes, square root of v squared. No, I will not always show that step because you're physics 20. You all got through my math 30, sorry, my math 20 and my math 10 class. You know how to take the square root of a number. Now, getting back to this review, these are all the formulas you need. Okay? Now, just to screw things up, we're going to do vertical. How many of you guys have ever been on a roller coaster? Puke? Get sick to your stomach? Scared? Yes. Okay. So, you do the loop-de-loop in the roller coaster. Now, the trouble with this is when you're anywhere, you've got force centripetal and force of gravity, force centripetal pulling in and force of gravity pulling down always. So, this sucks because you've got triangles and you've got a whole lot of trig. So we cheat. Well, sorry, we don't cheat. We look here at the top and here at the bottom. Okay? Now, if you're at the top here, upside down, here you are, upside down, your hair hanging down because you're young and you have hair. What forces are acting on you? What's always acting on you? Yes. So force of gravity is acting down. What other force is acting on you? Centripetal. No, hang on. Yes, and? Well, it's not immediately obvious because you're scared at the time, but if you're there, you have the seat pushing into you. Normal force or tension. Now, it's F normal, two objects touching. So, if you're sitting there in a seat, we're talking force normal. If it's a weight on a string, or a rope or a chain or something, then we haven't got normal force, we've got force tension. So, with rope you have a tension. So it's one force or the other. Now, somebody said force centripetal. Yes. The centripetal force is the net or the sum of the forces acting down. Okay? So that's half of what you have to remember for today. The other half, you're here at the bottom. Which way is force of gravity acting? Down. Which way is the normal force acting? Up. Or, if it's on a rope, it's tension. So centripetal force, for centripetal, it's net force. So we don't normally talk about this at an angle. We talk about straight up and straight down. Keep the math simple. So I'll talk about at the top of the loop or the bottom of the loop. All right? So far, so good? Okay, I'll let you finish copying that out. And once again, we have two forces, normal force and force of gravity, or tension and force of gravity equals the net force. But here we call the net force centripetal force. Yes?
At the top of the roller coaster, wouldn't force net be force centripetal plus force of gravity?
Sorry?
Would force net be force centripetal or whatever plus force of gravity?
No. The net force, or the sum of the forces, is acting directly into the center. We call the force acting in the centripetal force. So here you can call it the net force or you can call it the centripetal force. It has two names because it's going directly into the center seeking centripetal force. Now, let me give you an example. Here you are upside down in the roller coaster. Woohoo! This is 4,800 kilograms. You're going that way at 13.8 meters a second. Oh, and this radius r is 4.8 meters. So what's going to happen? Well, you're out of math class or physics class. You're having a good time. What else is happening? Yes.
Your momentum is so strong that the gravity that was supposed to be pulling you down is actually greater. So
Well, let's not deal with momentum yet or inertia. You're on the right track. Save that for next year. What's going to happen here? You guys that have been in the roller coaster, what happens? Well, you shouldn't black out. You keep on going. But right here at the top, what have we got? What two forces are acting on you? Force of gravity and there's no rope pulling on you, so it must be the chair pushing into you. Now that's kind of counterintuitive because you always think force normal goes up. But think about it for a sec. What's happening to this cart? It's going this way. So what's going to happen? You want to keep on going this way. Remember Newton's first law, an object in motion stays in motion? So you want to keep on going this way. What's happening to the cart? It's coming down and pushing into you. So you're getting a normal force pushing you down instead of up. And that's a conceptual problem so many people have. This is where I really think we should do a field trip to the roller coaster in Edmonton, but I can't get a bus. Or I can't afford it. So yes?
So when stuff like that happens and you're going upside down, is the roller coaster actually connected to you?
Yes.
It's not using momentum just to keep you.
Now, I don't want to be using momentum because we haven't talked about that. Momentum is mass times velocity, and we save that for physics 30. Okay? But what happens here, Newton's second law says an object in motion, you keep on going this way because you want to. What happens to the cart? Well, the cart has this track in the way, so the cart's going like this, pushing down on you. And that pushing down on you is the normal force. Now, once again, like every other question we've done for the last month, F net is the sum of the forces. Now in this instance, it's force of gravity plus force normal. Since this force is acting to the center, we don't have to call this net force. We can also call it force centripetal. Now, I don't want to use net force here because your first thought is mass times acceleration, which is good. But this is centripetal acceleration, so it's mv squared meter. So they're saying it's centripetal acceleration, mv squared over r, not ma. Now, what's force of gravity?
9.8.
No, that's 9.81 is acceleration due to gravity, little g. Force of gravity is mg. Now, I haven't asked a question yet. All I've done is blathered on and put some equations down. Yeah, a normal Friday afternoon for me. So, you guys, we know mass, we know velocity, we know radius. Can you tell me the normal force pushing down on you in this cart? Please. Calculate it. Now, once we get to this point, you realize the math isn't hard. But there's a few little tricks, and you got to be careful about this. I don't recognize him. Don't want to know. I'm just going to keep on going. It's safer that way. All right. So, what's going on here? We know mass, 4,800 kilograms. The velocity is 13.8 meters per second squared divided by the radius, 4.80 meters. Now, before we go any farther, which way is this force going? What's the direction of the centripetal force? To the center, which in this instance is down, which makes this negative to show the direction. Now, mg is 4,800, 48 and 4.8. That was a crappy move on my part. Anyway. Now, which way is acceleration due to gravity? Down. Thank you. That should be minus. So, everybody grab a calculator and help me out here. 4,800 times 13.8 squared divided by 4.8.
Isn't force normal just opposite of force gravity?
Nope, not in this instance. Usually it is, but this is the force of two objects together. And it just so happens they're upside down just to completely screw things up. And that's, yes, as I said, getting back to this conceptual problem, that's what people find really hard here. So, now he's awake. Grab your calculator, plug the numbers in, tell me the force centripetal. I don't have a calculator. Minus 4,800 times 13.8 squared divided by 4.8 is what?
143352.
143352. Okay. Negative newtons. Okay. Now, 4,800 times 9.81 is? Oh, fine. Dudes. I was going to say that. It's a little off. All right. One more time. 190,000. That should be negative. All right. What's force of gravity? Negative 47088 newtons. So, how do I get force normal all by itself? Add 47,088. So force normal is minus 144. Okay, somebody speak loudly enough I can clearly hear you. 14335. So, the roller coaster is pushing down on you 143,000 newtons. So that's the pressure you feel going down. Now, I could also word the test question, and I will. What force does this have to withstand? The track has to withstand this much force. Because if it can't withstand this much force, it'll break. And we have another accident.
The reason on the negative is there because it's
pointing down. Because you've got two objects, as I said, Gabe. You've got your cart going like this, and you've got the rail. The rail goes like this. The cart gets pushed down. The cart wants to go straight. Newton's first law, an object in motion wants to keep on going in the same direction until there's a force applied. The force is the cart going down. That's the normal force, 143,000 newtons. If the rail can't push that far down, it'll break, and you go, and it gets very bad. Yes, but I believe they jumped the rail. They didn't break it. But every once in a while you read about it, a roller coaster, and it's not good. Anyway, now I want to point out the math is nothing we haven't done before. It's this upside down, and the normal force is negative going down that always hurts people's brains. Conceptual problem. Now, it kind of sucks, but looking at the same roller coaster, keep the math simple, 4,800 kilograms, R is 4.8 meters. The next question I will always ask, well, not always, but I will ask it, V minimum. There's a minimum speed necessary to make a circle. So, I will demonstrate this later with a bucket of water, but not near all this fancy electronics. If you have a bucket of water and you start spinning it in a circle, you can go as fast as you want. You've done this and you know you have to apply a force. But if you slow down, less force, and there's a point, it won't make a complete circle. So if this was a bucket of water, I'd be dry, I'd be wet. Well, I would be. I'd swing it in a big circle like this. You gotta be careful because of all the electronics. Bigger circle, faster. Notice it's over my head. There'll be a point where I get wet. So what I'm trying to say is there's a minimum speed here. One of my favorite questions. What's the minimum speed? And I will demonstrate this with a bucket of water away from the electronics if you get your homework done tonight or on the weekend. Now, here, what are the two forces acting on this? Force of gravity and force normal. Now, here's the key. Velocity minimum means the two objects are no longer pressing against each other, or F normal is 0. Okay? So one thing you have to remember for this. So, force centripetal, the other force of gravity. Force normal is 0. So to just make it through, all you've got to do is be equal to the force of gravity. Now, plugging in the equations, mv squared over r equals mg. Now, if you actually read the textbook, they get a little more complicated about this, and they like deriving a certain formula for each situation. I don't. I'm hoping you can remember this and go, oh, mass cancels out. V squared over r equals g. Can I rearrange this to solve for v? Yes, what do? I'm divide by r. How do I get rid of divide by r? Times by r. V squared equals rg. Now, as I said, a lot of physicists want you to memorize this formula. That's the minimum velocity formula. If you go to Khan Academy or you look at my old videos, I used to make you guys memorize this and write it out. But what I'm trying to do, get the formulas and rearrange it. I think that's easier than memorizing all the different versions. Whatever keeps you happy. Whatever works better for you guys. Either way, when I'm talking minimum velocity, So what's the minimum velocity here?
6.9.
So as long as you make 6.9 meters a second, you're not going to fall. If you're slower than that, you fall out of the chair, which is why you have those strap things. And that's why this is designed to go faster than 6.9, so you're pushed into the seat. Because there's always some skinny person that's going to fall through, or some idiot that's going to wiggle loose just because he can. Yes?
Well, even though we're using gravity here, is there a reason why 9.81 is a negative this time?
Well, here we always go, it's down. And technically, the radius is also negative, because it's a distance going down. I don't like putting in all the negatives. It confuses people. Okay. So just leave it at 6.9. Now, this works all the time. My personal favorite version of this, how many of you guys drive? You ever go to Peace River? You know down where they're doing that, they were working on that road, there's a couple of hills there? Do you ever accidentally go airborne on one of those?
My dad did once.
No comment. No comment whatsoever. No. Shh. No. No, guys. This airborne question works, velocity minimum works regardless of where you are. There's going down into Peace River, there's one of those hills. It has a radius of 40 meters. What's the minimum speed you need to go to get airborne? Not that you should find out. This is a theoretical question. This is not your homework to go find it and prove it. Shh. What's the minimum speed you need to get airborne here? All the guys are smiling and all the girls are looking serious. God. There's a reason the fire department has 3 sets of hydraulic cutters. All right. What's the radius? 40 meters. Acceleration due to gravity is? So what's the minimum speed you need to get airborne here?
19.80.
Sorry?
19.80.
19.80 meters a second. What is that in kilometers an hour? You multiply by 3.6 and you get? 71. Sorry?
1.36 to get that to...
Oh, kilometers an hour. Never mind.
To get meters per second to kilometers, it's 1.1.
Divide times 3.6. Right by the flag. That gets you into low Earth, or never mind. That gets you into lower. No, that gets you into escaped gravity. You can go to Mars with that. Anyway, never mind.
Nice.
Shh. No. All right. So, one of those hills that has a 60 kilometer an hour warning sign on it is actually if you go 71. You'll find that easier if you go to Blue Bridge because that hill is a heck of a lot worse. When they say 35, it should say we freaking mean 35. I hit one of those bumps doing 80 in the fire truck, and I ended up in the opposite lane in oncoming traffic. 80 with a fire truck. Yeah.
Did you hit the roof? Like 3 times?
No. Fortunately, there was enough headroom in there. I was buckled in tight. I didn't hit myself, but the car went bwanga, bwanga, banga. Anyway, so I'm not kidding. I went airborne.
There's really not that much traffic on Blue Bridge.
Thankfully.
Luckily, yeah.
Except for 3 other fire trucks, an ambulance, a police car, and a bunch of other guys. Yeah. Yeah. Anyway, so one thing: obey the speed limits. And when they say 35 on Blue Bridge, they freaking mean 35. Because honestly, as I said, I was doing 80 and I went airborne, and I went into the oncoming lane. I suspect I would have gone airborne about 50. It was really bad. No comment. All right, now. Okay.
Any more examples?
Oh, yes, a couple more. Now.
when a force needs to equal out would be greater than?
Yep.
Okay.
Or normal force is always 0. Now, here we go. So here, the car is at the roller coaster car. Sorry, the 4,800 kilogram roller coaster car. 4.8 meter radius. What is, velocity is 13.8 meters a second. I want to know force normal now. Now, shh, guys, stop. So, the opposite, the trick here with this is you're either at the very top or the very bottom. You have to draw a picture. Now, if you're not going to copy out the notes, I'm okay with that. Some of you guys can just look at this and memorize it and get it. Congratulations, I'm jealous. But I'm looking at you, yes, and I'm not mentioning names because of the video, but because this is going to be posted this afternoon. But you really better have this done for homework because I'll be calling your mother. Now, here, what's the normal force? I don't know. What do I know?
How much your weight is? The radius?
Yes, I know the mass.
Yeah.
Mass and weight are different things. Angel, what do I know here? Yes, I know the mass.
Force centripetal to force of gravity plus.
Yes. Force centripetal, force gravity plus force normal. Getting ahead of myself. Try this again. Me speak English. Try this again. What forces are going where? Yes.
Force normal should be going down.
Careful. You got two objects pushing against each other. If you're here, force normal is pushing up. Which way is force gravity going? Down. Force of gravity always goes down. Now remember, this is force normal because it's two objects touching. If it was weight on the string, it would be tension instead of force normal. So the next question could be, what's the force on the string? Or, like I did at the beginning, what's the maximum velocity before the string breaks? That sort of thing. Either way, here we go. Force centripetal, what's the formula for it? Force of gravity is mg. Yes?
Is gravity negative?
Yes, gravity is negative or going down. Which way is centripetal force going? Up. So it's going to be positive. Now, you'll notice, exact same radius, exact same velocity, exact same mass as back here. I deliberately chose that because now I can take the bacha, and I meant that. Now, if you copied this out already, all you got to do is peek back. Oh, wrong one. And paste down here. Because, let me see. Here. Oh, yes. This is up. So this is plus 190,000.
Oh, so you just flip them around.
Yeah. That's why I chose same mass, same radius, same velocity. It's the exact same numbers except this is plus going up. Centripetal force. So the normal force, we add them together and we get what? Yes?
Cancel out the masses on each side.
Well, trouble is force normal doesn't have a mass involved. Now, so what is 190 plus 47,000? Those of you with the new TI calculators can just scroll up and change the minus to change the minus to a plus and tell me it's what? 200 and 500. That's plus or up. So what happens here, you want to go straight forward, Newton's first law. The road gets in the way, or the track gets in the way and pushes up on you, so you feel heavier. This is the exact opposite of going airborne. If the road's falling away from you, you can go airborne. If the road's going up, you're pushed into it and you feel heavier. So which is more fun? Airborne. Yes?
Is that negative 9.81 now, or is it still negative?
It's still negative because it's still going down. Gravity is always going down. What I'm stressing here is this is going up, so this is plus 190,000 now. It's like you have to draw the picture and you have to go, oh yeah, force normal is going up, so that's positive now. Oh, sorry, force centripetal is going up, so that has to be positive. And normal force is going up, so that's got to be positive also. So, remember we talked about g-forces in the airplane with the toboggan? This is the same thing. You're feeling extra heavy because of the curve. Now, I don't even want to think about how fast you're going to have to go to feel 3g. That would probably wreck your car. Oh, yeah, let's not find out, and that is not a homework assignment. God. Okay. Okay. Now, one last question, and then I'll be quiet and leave you guys alone. Mr. Sutton is swinging at 240. Question or stretch? Okay. Okay. No, that's too heavy. Mr. Sutton is swinging a mouse in a circle like this. Now, let's do this at the video so they can see it. Now, that's vertical circular motion. As once again, we talk about at the top or at the bottom only. In between, we got forces and angles, and I don't want to do that math. It hurts too much. So, 245-gram mouse. The cord is 35 centimeters. Tension at the top if V is 5.67 meters a second. So, yes, you may. Now, guys, get this done. Show me you understand it. I'll be quite happy and leave you alone. Give you a chance to work on your homework. So, what am I? Have trouble reading it? Okay. Color or 35 centimeters. Okay. Thank you.
You don't give us radius now.
That's distance, isn't it? So that must be. Oh, I did say the cord was 35 centimeters long. So I'm getting lazy and I don't want to write everything out. Well, that and I'm trying to, and more importantly, besides being lazy, I'm trying to train you guys to pay attention. Like I said, the nice policeman says driver's license, registration, proof of insurance. Yes, you hand it over then. What's mass?
Oh, I was actually asking if the M4 pi squared R over T squared actually works for this.
I think so, but hang on for a sec.
Okay.
What's my mass?
245 grams.
Okay, so what's two standard nasty little tricks have I done? Yes, Angel? Wrong units. What units should they be? Okay, so this is how many kilograms? Careful. Thankfully, nobody here's a drug dealer. How to turn grams into kilograms? Say? Divide by? 1,000. Someday when the video camera's off, I'll tell you the story about when Canada went from imperial units to metric units, and it was Cheech and Chong that did so good in this unit. But anyway, 35 centimeters is how many meters? Centi means 100th. Yep, divide by 100. Now, Gabe said something earlier, but I was concentrating on this, and I missed part of what he said. But I'm assuming, of course, you've all drawn a picture. Why are you all of a sudden starting to copy what I'm doing? That confuses me. What do we know here?
We know tension, we know mass, and we know radius.
velocity is 5.67 meters a second. R is 0.35 of a meter. Now, what are the forces? Louder. JJ, what are the forces? Sorry? Okay, we've got force of gravity pulling down. But what force normal is two objects rubbing together. We don't have two objects rubbing together. We have strings, so it's tension. Big, hairy difference. Force centripetal, force gravity plus tension. Now, Gabe, I believe you were giving me an equation, and I missed part of what you said.
It was I don't know if it's work or not, but it's the M4, the mass of 4 times pi squared times radius divided over.
You can do it that way, but what I want you to be able to go mv squared over r equals mg plus t, the basic version of that. Now, we could talk about period frequency. Yes, we can rewrite the... I haven't done an example like that, have I? Of the, yes, mass 4 pi squared r divided by t squared. If I ask for the period, yeah, that would be a good one to use. Okay, now, I guess I should do one of those, but not today. Give you one of those for homework just to hurt your brain. You got mass, you got velocity, you got radius. What's the tension? Figure out what the tension is. Tell me, and I'll give you. And I'll let you work on your classwork. Woohoo! Woohoo! Well, I thought half the class would be going, so I moved that to Monday, because I thought it was more of you going to that French thing today. Okay. Well, Monday I'll give you catapult time. Okay. Right. Did you get? Come on, show me some numbers. You guys are starting to get this, so come here, boy. Come here. All right, I'm going to turn this off. The answer is what? Tension is 20, I believe.